your steps to eliminate. First thing you have to do is find some variables that will eliminate. So in a nice, easy equation, you'll have opposites already, like a 2x and a negative 2x. If there are none, you might have to multiply one of the equations to make the variables opposites and or change the signs. Once you've done that, you're going to eliminate those opposite variables and everything else gets added together vertically. You're going to solve for the remaining variable just like a normal linear equation. And then same as with substitution, at the end you substitute into one of the equations to solve for that other variable so that every answer has an x and a y. Good times to use elimination when you already have a pair of variables that will eliminate. So you already have a positive 2x and a negative 2x. Or if your two equations are already written in standard form so that the corresponding terms are lined up. The x's, the y's, and the constants all go together. First example for you. Great time to use elimination because I have a pair of opposites here. I have a positive y and a negative y. So those will eliminate, and I add everything else. Negative x plus negative x is negative 2x, and negative 7 plus 1 is negative 6. Solve for x, I divide by negative 2, and I get x equals 3. Now my answer needs to be an ordered pair, x, y. So I have a 3 for the x. I need to find y. I can go back into any of these equations and put the 3 in. So I'm going to just pick the top equation. Negative x plus y equals negative 7. Instead of a negative x, I'm going to substitute in. So I have negative 3 plus y equals negative 7. To get y by itself, I add 3 to both sides. I get y equals negative 4. So solution to this system is 3, negative 4. For my second example here, I have 6x and 6x. Those are not yet opposites because they're both positive. So I pick one of my equations and I change all the signs. So I'm going to pick the top equation. I'm going to make that a negative 6x. This negative 8y switches to positive 8y. And negative 24 switches to positive 24. Now 6x and negative 6x can eliminate. Everything else gets added. 8y plus negative 7y is just 1y. And 24 plus negative 21 is 3. So in my ordered pair x, y, I know that y is 3. Oops, I wrote a y instead of a 3. Now I substitute that in. I can pick any of the equations. I'm going to pick my top one again. So negative 6x plus 8y equals 24. Instead of y, I substitute in a 3. Negative 6x plus 8 times 3 is 24 equals 24. Subtract 24 from both sides. I get negative 6x equals 0. Divide by negative 6, I get x equals 0. The solution here is the ordered pair 0, 3. Last example, here I don't have any opposites, but I could do some multiplication. So I have a 3y and a 6y, and I know if I multiply that bottom equation by 2, then those are both going to be a 6y. So the top equation stays the same, negative 7x plus 6y equals 16. Bottom equation, I multiply everything by 2. So 2 times negative 9x is negative 18x. 2 times 3y is 6y. 2 times 30 is 60. Now in this case, I also need to change the signs because those are both positive. One option would have been to multiply by a negative 2 from the get-go. Otherwise, I'm just going to change signs here. So positive 18x, negative 6y, and negative 60. Now my y's will eliminate, and I can add. Negative 7x plus 18x is 11x. 16 plus negative 60 is negative 44. Divide both sides by 11. x equals -4. I can substitute that -4 into any of my equations. I'm going to go with the first one. -7x plus 6y equals 16. Substitute in -4 for x, I get -7 times -4 plus 6y equals 16. That makes it 28 plus 6y equals 16. Subtract 28 from both sides, we get 6y equals -12. And divide by 6, y equals -2. My ordered pair here is -4, -2.